Here you see I have a circuit set up. I initially have this parallel branch that is connected to a single resistor that's connected to another parallel branch. All right, so how do we tackle this when it's not just parallel and it's not just series, but it's what we consider a combo? Well, we try to simplify it the best we can to get it to a series circuit ultimately. And then we could just use the series rules to add up the resistors and then go about our business as usual. So, for instance, if I have all the resistors being 8 ohms each, then I would use my parallel rules to get this component here. 1 over 8 and 1 over 8 is 2 over 8 or 1/4. You flip that over and you get an effective resistance of 4 ohms. This is 8 ohms. And since this is identical to the first parallel branch, it also is 4 ohms as its effective resistance, right? So how do I redraw this as a simplified version? Well, I would just draw a 1 resistor of 4 ohms for this parallel branch. This would remain the same as 8, and this would be identical to the first one as a resistor of 4 ohms, right? So now I have a 4, 8, and 4 ohm resistor that are in series, and we could just add them up to, once again, be a more simplified version of just a 1 resistor, and what has a value of 4 plus 8 plus 4, 16 ohms. And now we have the total resistance and the total voltage of 100 volts. We could go ahead and figure out what the total current is. Also, it's going to be important to know what the voltage is across each component of the circuit. So for this part here, right, and these both have the same voltage, well, what is the voltage going across these guys here? Well, we know that there's a total current of 6.25 going through that component, and it behaves like a resistor of 4 ohms. So 4 times 6.25, my IR, gives me 25. That 6.25 amps is going through this 8 ohm resistor. That's 50. And then this one is the same as the first one. That is also 25. And so we have 25 plus 50 plus 25 equals 100. And that is saying that each resistor up here each has 25, because that is the rule for parallel. They both have a 25 voltage going across them. This has a 50 voltage across it. And this has a 25 voltage across that part. Lastly, let's go back to the top again and look at the current going through each resistor. And since these are both of the same value resistance, the top and the bottom, each of 8 ohms, they're going to carry the same amount of current through them. And so if the total is 6.25 and it splits equally, then each branch gets that 3.125. The current comes back together again and continues along a single wire there, so that resistor by itself will get the total current of 6.25. And then lastly here, the current splits again, goes across the top and bottom branch. Since they're of equal resistance, they will also carry equal current, splitting the total in half, 3.125 amps each.